the motor effect and the generator effect. In the motor effect, electrical energy is converted into mechanical. A current carrying wire is placed in a magnetic field, and so the moving charges in the wire experience a magnetic force. Because the charges are contained within the wire, when the charges move, the wire moves. Electrical energy converted into mechanical. With regard to the figure, in what direction will the wire move? We need to know which way the magnetic field is directed. Outside of a magnet, the magnetic field is directed from north to south. So basically where this wire is, the magnetic field is pointing to the left. If we use our pat-pat right-hand rule, pat-pat, where our thumb points in the direction of the current and our fingers point in the direction of the magnetic field lines, you can see the force is going to be pat up like that. In the generator effect, mechanical energy is converted into electrical. A metal wire, not carrying a current at the moment, is placed in a magnetic field. The wire is made to physically move via some outside force. The charges trapped within the wire must move along with it. And when charges move through a magnetic field, a magnetic force on those charges arises. This magnetic force is at right angles to the original motion, which was due to the outside force, you remember. And the magnetic force acting on the charges in the wire produces an induced electric current. Mechanical energy converted into electrical. We have the same setup here, but right now there's no current moving through this wire. There's our magnetic field. I'll just draw a couple of lines there. And now what we're doing is the charges in that location are moving up. Point our right thumb in that direction. Our fingers are going to point in the direction of the field line, and you can see the induced current is going to go that way along the wire, kind of out towards us. It's a perspective drawing. Let's finish this video by talking about a simple motor here. Here's a basic diagram of a motor. We've got permanent magnets. That's the north pole of it. That's the south pole of it. We could have two separate magnets, with that being the north pole, that being the south pole. Maybe we have a horseshoe magnet where it goes up here to the top of the screen and comes back down. In any case, you have a permanent north and south pole there. The key feature of a simple motor is the split ring commutator, which is this device right here. And you can see there's a little split right there. Let's figure out what's happening. Down here at the bottom, we have a battery or something that is causing current to flow in this direction. So here we have current flowing in. You can see the little arrow that I'm pointing at. There's current going right there, which means right now there's current in section AB. There's current going that way, kind of away from us. In what direction will that segment feel a force? Using your pat-pat right-hand rule, you put your thumb in the direction of that current, and you put your right fingers pointing in the direction of the magnetic field, which is from left to right, then you can convince yourself that section AB is going to feel a magnetic force downward. Now, what about section CD? So here comes the current. Watch my marker here. Current's going this way, and then through CD, it's coming this way. So if we use pat-pat with that, then what's that going to give us? Well, it's going to give us an upward force. So CD feels an FB that's upward. So what does that mean? That means that this loop is going to rotate. If AB is forced downward and CD is forced upward, this loop is going to start to rotate. The loop rotates. Then what happens? AB is going downward, CD is going upward, and at some point you can see here, so CD is going upward. So basically this portion right here where my marker is, eventually it's going to get up to right there. The loop rotates, and then it jumps this gap right here because it's got some inertia, right? It's going to keep going. It's not just going to stop immediately. It's going to keep going. So it jumps that gap. And when it jumps that gap, what was CD in this picture now basically becomes AB, because as soon as CD jumps that gap, now it's on this side, it's on the left side now, and it basically becomes AB. And we established about 3 minutes ago that the AB portion feels a force which way? Downward, which means that CD was coming up, then it jumps the gap, and as soon as it gets here, CD feels a force downward. Well, similarly, AB on the other side will feel a force upward. So what's going to happen? This loop just going to keep right on going. It jumps that gap. Let's just put this in words so that CD feels an FB down and AB feels a magnetic force up, and literally round and round we go. If you didn't have that split ring commutator, this loop would only rotate, a fourth of a turn or so, and then it would just stop and not go any further. The whole key to keeping this motor going is having that split right there so that the loop is allowed to continually go around and around and around as a result of this magnetic force.